If you're anything like me, at times you probably feel like you're bombarded by the media and maybe some of your friends about microplastics, how bad they are, how much microplastic is in the ocean, and how much is in our bodies, what we need to do to fix it. But with new data, new schools of thought, differing headlines, and swathes of information, it's difficult to know fact from fiction and truth from speculation. So I've done a deep dive looking at the detail behind some of the recent headlines and studies. I'm going to take you through what I've found, including how little we actually know about microplastics in the ocean, speculative science that makes it into some of these studies, and the sensationalized media reporting that only serves to muddy the water. So here is the full context you need to know about microplastics in the ocean. For those of you who don't know me, I'm Tim. I'm not a specialist in microplastics, but I am a specialist in critical thinking, assessing risk, and data analysis, skills I use every day to understand the grey areas we live in. Because I'm not a specialist, I'm not going to ask you to take me at my word, and I will always show you where the information is coming from. Before we start, you need to know that our knowledge on microplastics is pretty limited. The impact on our health and the environment is still relatively unknown and is filled with speculation and wild extrapolations, all of which we're going to be looking at in this video. It does not mean that microplastics are not a problem. I think we can all agree that microplastics floating around in our bodies, our drinking water, in the oceans is not a good thing. But hopefully the full context can pave the way for a better and more reasonable discussion about how we tackle a microplastic problem. Now, my interest was first piqued when a friend of mine shared an article a while back, but I forget the exact details. The headline read that there were some hundreds of millions of microplastics in the ocean, and I was curious in equal parts because 100 million tons is a big number. Secondly, how do you even measure the weight of microplastics in the ocean? And third, you may not know this about me, but I like to tell people that they're wrong. So I'm going to take you through a similar study. This study is entitled High Concentrations of Plastic Hidden Beneath the Surface of the Atlantic Ocean, written by researchers at the National Oceanography Centre. Now, the BBC headline about this study read, "There could be 200 million tons of plastic in the Atlantic, according to new research." So let's see how they arrived at this 200 million number. Well, in short, they took a boat to 12 locations. For reasons I can't fathom, they are labelled 1 to 30 in the study, in the Atlantic Ocean, and used a pump to gather around 1,000 litres of water at 3 different depths at each location. So 3 depths, 12 locations, 36 samples taken. The deepest they took the samples from was around 200 meters. Now remember this, it's going to be important later. They filtered the water samples using a fine mesh. They boiled it and a whole bunch of other stuff, and they're basically left with just the microplastic. They put these samples into a 200 milliliter flask of water, and then from that 200 milliliters, they took just 36 milliliters. For anyone struggling to visualize, 36 milliliters is around 1 shot glass of water. Now this is where it starts to get a little bit silly. They look at this shot glass of water in a 2D plane, and they measure the size of the particles in the water in 2D. In theory, they know the approximate density of plastic, and therefore you can work out the mass, because mass is volume times density. But how can you be comfortable that your 2D pictures are giving you an estimate of the size of the plastic? It could be like this, or it could be like this. So here's the thing, you have to make a guess, and the authors of the study make an estimate in 4 different ways, all giving a similar result. But they only measured a total of 1,444 microplastic particles in this entire study, with an average weight per piece of 0.5 micrograms. So that means that there's a total weight of around 722 micrograms of microplastics in the whole study. And for context here, a microgram is 1/1,000,000th of a gram, and 722 micrograms is approximately the weight of 1 human hair. The study then extrapolates 722 micrograms across the entire volume of the Atlantic Ocean to estimate between 11 and 21 million tons of plastic in the ocean. This means the extrapolation was 2 times 10 to the 19, 20 quintillion, or a million, compared to the actual result. That's like picking up 1 grain of sand and thinking you know how many grains of sand are on this earth. The margin for error here by extrapolating over such a large area is huge. The only thing we can say for certain with extrapolations of this magnitude is that it's definitely not right. You also don't have to take my word for this. A peer reviewer on the study commented as their opening remark, "I consider the data has to be taken with caution and analysed more carefully in order to make such large extrapolations, which doesn't mean the conclusions are not valid." And these results are not invalid. They are interesting and certainly point to a higher concentration of microplastics than you might have thought, but you have to treat them with caution because the extrapolation is just so ginormous. Which brings me back to the headline. Now, didn't that headline say 200 million tonnes? But the study explicitly states an upper limit of just 20 million tonnes. This has arisen because the article does not quote directly from the researchers but simply states the volume of water used in the samples were limited. The scientists believe that if they take the figures from their research and apply this to the full depth of water in the Atlantic Ocean, which is around 3,000 meters, then this suggests the ocean is actually carrying 200 million tons of plastic litter. This is an even crazier extrapolation because the data in the study showed that the concentration of microplastics actually seemed to reduce at a lower depth. And I'm certain the reason the study doesn't extrapolate the entire depth of the ocean is because the peer reviewer would have identified the absurdity of it, given that the samples were from the relative surface. Let me clarify. Extrapolations aren't inherently bad and are useful in statistical analysis, especially when the entire population, in this case the ocean, would assume to behave uniformly. But in this instance, not only do we not know, but we have some data indicating that it doesn't behave uniformly, i.e. the concentration of microplastics reduce at depth, so you cannot extrapolate deeper than your deepest sample. For instance, good extrapolation. Every morning since I was born, the sun has come up. I therefore expect it to come up tomorrow morning. The sun rising behaves uniformly. Bad extrapolation. When I was 4 years old, I was 3 foot tall. Now I am 19 years old and I am 6 foot tall. When I am 49, I will be 12 foot tall. We know that humans do not grow uniformly over their life. What kind of hurts me even more about this whole situation is that the headline is from BBC Newsround, and this is news for kids on the BBC. Grown-up BBC News covered the study with the headline of "Microplastic in the Atlantic Ocean could weigh 21 million tonnes." So there is no mention of the 200 million we saw in the other article, and it does make me wonder why the same organisation would have two egregiously different headlines covering the same subject and indeed the exact same study. Hopefully you can see from this example how these studies approximating from very small numbers are nothing more than a best guess based on very limited data. No one has trawled the length of the oceans, or even a significant amount of it, to tell you how many microplastics there are, and even if they had, they would be guessing at what they found using a 2D image of a thimble of water. Now, I'll tell you what else is the size of a thimble of water, and that is my subscriber count. If you're enjoying this video, please like and subscribe to help me out. Anyway, what I hope I'm getting across here is that we don't know the level of microplastics in the ocean. This doesn't mean that we can't use the estimates we have to make educated decisions, but it does mean that we shouldn't sensationalize the number, think of it as fact, or draw radical conclusions. Now, we know that there are at least some microplastics in our ocean. There have been several studies showing that microplastics exist in our drinking water. Unfortunately, some of them are locked behind a paywall, meaning that we can't really interrogate the studies without having to pay for them. Suffice to say that their estimations won't be any better than our estimations for the ocean. But we can look at some analysis done for the WWF. That's the World Wildlife Federation, nothing to do with professional wrestling, and that comes from 2019 and gathered media attention at the time. They commissioned a study from the University of Newcastle in Australia to review the existing literature. This study is again locked behind a paywall, so we can only comment on their conclusions without knowing all the methods that they employed. The headline conclusion they drew is that we ingest approximately 1 credit card's worth of microplastics, or around 5 grams, every week. And this estimate is almost entirely from our drinking water, where they estimate 1,769 individual pieces of microplastic every week. What we don't know is how much water they're estimating we drink, because it's behind the paywall, And we can see how many microplastic particles there are in the ocean study though. At the very highest end of the ocean study, in the most heavily microplastic populated water samples, they approximated in the region of 3,000 pieces per cubic meter. A cubic meter is around 1,000 litres. So using a sensible estimate that we are drinking 1 or 2 litres a day, the implication here is that our drinking water has 50 times more microplastic than the most microplastic heavy sections of the Atlantic Ocean. Now, I can't say if this is unrealistic, we simply don't know, though possible I would have a better idea without paywalled information. I can say that both numbers have been arrived at using enormous extrapolation and assumptions, and the disparity here doesn't really make sense to me. I just want to point out that this image from the study is not paywalled and highlights plastic as one of the variables, which I just thought was funny. I'm not even sure what plastic as a variable even means in a study about plastic. Now, I want to make sure a lot of credit is given to the WWF here, because I really like how they presented the findings in their report. They clearly highlight the limitations of the study in a separate box in their report and have a good amount of detail for the caveats they included. I can't help but think that this sort of thing would be an excellent addition to almost all scientific reporting in the media, particularly where extrapolations of this magnitude are used to arrive at a headline. A man can dream. The WWF report also does a really good job of being clear about the known effects of microplastics on human health. They very clearly state that the effects are not known and not fully understood. They point out that certain chemicals and components that go into making microplastics have been shown to potentially have health implications, but this does not mean we can know what dangers they pose to our health. Overall, more research is needed here, and we certainly cannot say that they are harmless. What I hope I've made clear is that we just don't know what level of microplastics are present in our oceans, in our water, or in our food, nor do we really know the impact that it may or may not have on our health. I'm saying this because we're grown-up adults who should be able to have proper conversations about what we know, what we don't know, and the risks that we should be wary of. We shouldn't headline our articles with unfounded estimations from authors when those estimations do not appear in the study, and we should caveat the limitations of the studies just as the WWF did. We shouldn't lock our papers behind paywalls to limit access to knowledge, and we should faithfully represent what we actually know. All that being said, my opinion is that we should be very careful about the risks posed by microplastics. Whilst we can debate, discuss, and speculate how much microplastic we actually are eating, drinking, and dumping into the ocean, we can't deny that it does exist. And we also know that there is potential for long-term health risks to us, damaging impact on the environment and to the wildlife. This is the long tail of risks that we should never underestimate. What will the situation of microplastics look like 10 years from now or 50 years from now? We don't know, but that doesn't mean that we should ignore it, pretend that everything is fine, or sensationalize an impending disaster. We can't see the future, and in this case, we can barely see the present, and I believe being honest about that is the best way to engage people in conversations that we should be having. There isn't an easy solution to the problem, no clear way forward, and no one thing that will clarify our outlook on microplastics. So talk to your friends and family, tell them what you think could be done, ask them what they think could be done. Maybe that's government action, maybe that's every individual doing their bit, or maybe it's corporate and manufacturer responsibility. Tell me in the comments what you think and make it clear when you're speculating. This was your full context on microplastics.